Okay, so this is objective 5. We are going to multiply and divide rational expressions. What's rational mean? Fraction. Okay, so we're going to multiply and divide fractions today. Okay, algebraic fractions at that. Binomials and trinomials and monomials. So here we go. We're going to start with example 1. We're going to start with monomials. First, does everybody agree that in each numerator and denominator, we just have monomials? Agreed? Do you have to have common denominators to multiply and divide? Yes or no? Do you have to have common denominators to multiply or divide? No. When do you have to have common denominators? And subtract. And that's what we're doing tomorrow. So, yee-hee! We're going to have common denominators tomorrow. Okay? But today, you don't have to worry about that. So, you could just start to cancel some things out as is right now. But I'm going to tell you, you know, once you start to mark this out, and mark this out, and mark this out, and mark this out, then people tend to lose like what they've marked out and what they hadn't marked out. Do you understand what I'm saying? Because there's so many pieces and parts to it. So I think the best method that I've come up with is let's just go ahead and multiply it across. Okay? And then we'll simplify it. So we're just going to multiply across. We're going to multiply our numbers with our numbers and our C's with our C's and our D's with our D's. And when you multiply powers, you add the exponents. So here we go. 6 times 15. Help me out. 90, I believe. What's C times C? C squared. And how about D? D squared. Divided by 5 times 8. 40 A D. Any questions about that? Okay, now we're going to simplify. Okay, now we're going to simplify. So if I simplify this, what does 90 over 40 become? 9 over 4. And if you struggle with that, you can always do 90 divided by 40. Math, enter. Calculator will help you out. Okay. How about my C squared and my A? They stay the same. So I'm just going to leave a C squared. And I'm going to leave an A in the denominator. How about my D's? Both of them? You can take one away from each. So if you take one away from here, that's gone. If you take one away from the numerator, you're left with 1 in the numerator. Okay? And there's your final answer. Now, let's go back to yesterday and let's talk about these excluded values. Okay? Things that the denominator can't be. So here's what I'm going to tell you. I'm going to shed some light on this a little bit, and we're going to do it with every single example that we do today. When it's just monomials, you can do it at the end of your problem, okay? Because, and we're focused on what the denominator is. The numerator can be anything. Does that make sense? Some people think, you know, can your numerator be 0? Can you take 0 and divide by 6? Can I take nothing and split it into 6 groups? Sure can. What would be in each group? Nothing. If you got nothing and you split nothing into nothing, you still got nothing. And so that actually does work. Okay, put it in your calculator. Put in 0 divided by 6. And tell me, does that work? 0 divided by 6. Does it give you an answer? What does it give you? It gives you 0. So it is okay to have a 0 in the numerator. That is, you know, perfectly fine. My question is, can you have 0 in the denominator? No, try it in your calculator. Put 6 divided by 0. What does it say in your calculator? error, and then it has a little colon and it says divide by 0. You do realize when it gives you an error, it will kind of guide you to what your problem is, what the issue is. And it's telling you the issue is that you're trying to divide by 0. You can't do that. Remember we got 6 people up the other day and we tried to split them into 0 groups, and we said you couldn't throw them out the window and you can't throw them out the door and you can't make them sit down, and then you guys told me, you said it's not possible. You cannot have a 0 in the denominator. So here's what I'm going to tell you. I'm not looking at the numerator. I'm only looking at the denominator. So tell me, what can A not be? A cannot be 0, because if I plug a 0 in right here, 0 times 4, anything times 0 is 0. And so that's not going to work, okay? And someone said, well, you got a D in the denominator right here. But here's the thing. If D is 0, I've got D's in the numerator. You follow me on that? And so if D is 0, that makes the numerator become 0, and then that makes the denominator become 0. What's 0 divided by 0? 0. Does that make sense? And so that one actually is okay. So that's why I said if it's a monomial, you can do it at the end of your problem. You just look at the denominator and you see what you could plug in for the variable that would make it 0. Okay? Because after all, it's all fun and games until you try to divide by 0. And you can't do that. Okay? All right, so let's look at the next one. What do we know about division? It's not hard. What do we know about division? We don't divide. We multiply by the reciprocal. Okay, repeat after me. We don't divide. We multiply by the reciprocal. We don't divide. We multiply by the reciprocal. Come on. We don't divide. We multiply by the reciprocal. We're excited. So, first things I'm going to do is I'm going to... Oh, thank you. Thank you. We copy. Thank you very much. Change to multiplication, and then we're going to take the reciprocal and we're going to flip it. Okay, so 35a squared b over 12x squared y. Any questions on that so far? Someone said, we're going to skip, flip, multiply. How many have heard that before? Skip, flip, multiply. If you understand that, you know, copy, change, flip, keep it, change, and flip it, multiply by the reciprocal. Either way you go. Okay? So let's multiply across. 18 times 35. 630. Thank you. Use your calculators to help you if you need. How about my variables? What will I have? A squared, b, x, y cubed. Okay? What's going to happen? Like, where do careless errors happen? I like to highlight those so that we don't make them. Where would careless errors happen with this? You know what someone said earlier? They said, my handwriting keeps getting me. How many, like, understand that totally? My handwriting keeps getting me, because if you write sloppy, you're going to miss something, okay? You're going to miss a variable. You're going to miss an exponent. You're going to miswrite something. So what I'm going to say is it's very important that you are cautious, careful, conscientious, and get every little detail, okay? 7 times 12. 84. Thank you very much. Then what will I have? A squared. B squared. Say that again. X squared and y. Okay? And let's simplify then. You can use your calculator. You can do 630 divided by 84. Math, enter, enter. I hear 15 over 2. Okay, how about my a squareds? Now, can we look for just a second about what the variables can't be? Like if I look at my a's, if a is 0, is it okay to, What happens up top if it's 0? And this would be 0. Would that be okay? 0 divided by 0? The whole thing would go to 0. What about my b's? If this is 0, if this is 0. Is that going to be okay? Yeah, it is. 0 times all of that is 0. And 0 squared is 0 times all of that is 0. And 0 divided by 0 is 0. Do you understand what I'm saying? Okay? Same thing with the x's. 0, 0, it'd be fine. Because you have variables in the numerator and the denominator, it's okay. Do you understand? Okay, because it just make it be 0 over 0, and it's just going to be 0. And so in this case, do I have any exclusions? No, because you have variables in the top and in the bottom, and if you plugged in 0 for each of those, then it would just be 0, and it's going to be okay. Okay? All right, so the A's cancel. How about the B's? 1B at the bottom. How about my X's? 1x at the bottom. How about my y's? Y squared at the top. So I think you're okay. Okay, and there would be your final answer. Any questions on that? Okay, moving along. Let's go to some binomials. Oops, excuse me. Do I need to multiply by the reciprocal? Do I need to flip anything? No, because this is multiplication. So we're going to revert back to our motto now, our old faithful. What's our motto? Factor, cancel, smush. Okay, so now we're back to binomials and trinomials. We're just going to factor, cancel, smush. Okay, so let me ask you a question. How many of the parts up there can factor? I'm going to factor everything I can. 3. Which part cannot factor? Yeah, x minus 8. So I want you to take a minute. Try to factor each of those trinomials. Okay, take a second and try to factor each of those trinomials. All right, so how would I factor this first one? X and negative 8 plus 2. Is it okay if I put plus 2 and then negative 8? That'd be fine. Commutative property says it doesn't matter. All right, and then on the bottom, I'm going to have an x and 2 negative 8s. Very good, Frankie. Times, this guy can't factor, so we're just going to leave him x minus 8. And then on the third one, I'll have x and plus 3 plus 2. Everybody okay? So factor what we can. Now, here is the point where with binomials and trinomials, I need to insert my exclusions. Okay? I don't want to do it after I cancel everything out. At this point, where would the world, if they were going to solve this, if they were going to evaluate this, you follow me on this? Where are they going to plug into? Into the question or into the answer? Into the question. So we got to look at this stuff once it's been factored before we cancel it. Okay, does that make sense? So help me out. What can x not be? What could I plug in right here for x that if I subtract 8 from it, it'll make 0? Because it's 0 times anything would make the whole thing go to 0. Do you understand that? So it would be 8. What else? Negative 2 right here. Everybody agree? Negative 2 plus 2 would make 0. So negative 2, and then one more? Negative 3. Okay, that's what x can't be. And someone said, do we really have to keep up with this? Okay, so let me explain this to you. Okay, I don't want to stress you out too much. I'm afraid to sit on this. I don't want to stress you out too much. Soon, in about a month or two, we're going to put in a little equals between that. and we're going to solve these as equations. We're going to solve rational equations, fractions, equations, okay? And here's the thing. You may solve the equation, and you may come up with like two answers. Let's say the answers are 8 and 3. 8, positive 8, positive 3. Everybody got that? Positive 8, positive 3. On the SOL, the answer choices are going to be 8 and 3. That's one choice. And so when you solve it, and let's say you did it correctly. You follow me on this? You did it correctly, and you get 8 and 3. But what's the issue? A minute ago, you told me that x can't be 8. Do you understand that? So what do? You call 8. You have to throw that answer out the door. You got to throw it in the trash. Even though when you solve it, you get 8 and 3. But because of the excluded value, because x can't be 8, you got to take 8. You can't use it. It's worthless. You got to put it in the trash. We call that an extraneous solution. Okay? And someone said, so what are you saying, Ms. Corns? You're saying, you mean I actually do the problem right and I get an answer, but it's not an answer. I said, that's exactly right. Does that make sense? It don't work. You get the answer, but when you plug it back in, if you plugged 8 back in, what happens to your problem? The denominator goes to 0. And what do we know about a denominator of 0? It's all fun and games until someone divides by 0 because you can't do it. So what would be the true answer of the equation? If you get 8 and 3, positive 8, positive 3, but you can't use the 8. It's worthless. So you have to throw it away. So what's the answer? Just 3. Does that make sense? So like on the SOL, one of the answers would be 8 and 3. One of the answers would just be 8. One of the answers would just be 3. And I don't know what the third answer would be. But you follow me? Like it's going to get confusing. So you're going to have to know your excluded values down the road. Okay? So don't worry so much as far as like the equation and the extraneous values go, things like that. But I want to tell you, you're going to have to understand that you cannot have a 0 in the denominator. I need you to understand that. How many understand that you cannot have a 0 in the denominator? If you get that. You can't do it. Okay? And I need you to be able to pick out what values of the variable is going to make the 0 in the denominator. Okay? And that's where your excluded values come from. So, we factor. Before we factor, we state our excluded values. Then we cancel out. Okay? So, what can cancel? X minus 8 and x minus 8. Anything else? You sure can. You can cross reduce. X plus 2 and x plus 2. Because technically, you know, you don't have to have common denominator. So technically, all this is going to get smushed together anyway. Okay? What else? X minus 8 and x minus 8. So what's left? So is the answer just x plus 3? Where is the x plus 3? Which one is it? 0 over x plus 3 or 1 over x plus 3? 1. Can't have a headless fraction. So 1 over x plus 3. Okay? Then do you understand, you know, if I just look at the answer to get my excluded value, all I would say would be negative 3, right? Because that's all I got left. But do you understand, if you're plugging into the problem, if you plug an 8 into your problem, that's going to not work either. So you got to look at it. You can't look at it from here. You got to factor it first, then get your excluded values, then you can cancel and smush it together. Okay? All right, what do we know about divide? Copy, change, flip. We don't divide. We multiply by the reciprocal. Okay? So I'm going to copy. Do notice that this problem has x's and y's in it on purpose. Y squared minus 3y minus 18. Would it be okay to factor and flip at the same time? Could I like flip it and break it apart at the same time? I don't know that I would do that. Okay, why? It's too much to keep up with. You're going to mess up. Okay, so here's what I'd like for you to do. How many of these things can factor? How many of the pieces and parts can factor? Here, 2, 3, all. All right, so help me out. How could this one factor? I see difference of two squares. GCF. Trinomial. Trinomial. So how many of them can factor? All of them. Okay, so factor them. Give me your excluded values and cancel smush. Okay, so let's see what we got here. How many could factor at least one of them? At least one? At least one? Like you could do more, but at least one? Okay. So how am I going to factor my first one? X and X and plus 4 minus 4. Okay. How about the bottom? Very good. 12 times Y plus 3. How many didn't do 12? How many did like 6, 4, 3, 2? What happens when you don't get the biggest out? You're going to have to refactor it, or it's just not going to work. Like, things won't cancel. Does that make sense? And then it's going to make your problem wrong. So you've got to get the biggest out. Okay? All right. On this one, I will have Y and Y. Then what? -6 plus 3. Okay? And then X, -8, -4. Okay? Now, before we cancel out, what do we need to do now? We need to help the world out. Okay? We need to tell them X and Y can be anything except, let's start over here with this one. What would make that whole thing turn to 0? So Y cannot be -3. What can X not be? How about, we don't worry about the numerators. Don't worry about the numerators. Just look at the denominator. 8 and 4. There's your excluded values. Okay? Everybody understand? I don't care what the numerator is. Numerator can be 0. That's fine. You just can't have a 0 under the fraction bar. If it's under the fraction bar, it's undefined. It's not possible. Okay? All right. What can cancel? X minus 4, X minus 4. Y plus 3, Y plus 3. Anything else? And so all we're going to do is take it and smush it together. So I'm going to have an X plus 4. I'm going to have a Y minus 6. Have a 12. And an X minus 8. Any questions on that? Okay. We have 2 more examples to go through. I want to show you something, okay? And this is for mainly, you will see this on your SOL, okay? You will see a fraction over top of a fraction. What kind of problem is a fraction over top of a fraction? What kind of problem is that?
Hard.
Nah, we're going to make it easy. That says A over B, what? Divided by C over D. So this is a division problem. So here's method 1. I call this the old school method. This is a division problem. So if you want to, you can write it out with a division sign like we were just doing. And then what would I do with it? Copy, change to multiplication, flip, and then if I multiplied it together, I would have AD over BC. Okay? There is a shortcut method. How many want to see a shortcut method? All right, if you are planning to go to trig, you're going to use this shortcut method quite a bit. Especially when you get into trig identities, and it's going to make things go really quick. So if you are planning to move on to trig, I would highly recommend that you look at method 2. It says this. There is a property that says if you have AB divided by C over D, it says you can take the very top and the very bottom and multiply them together and put them in the numerator. So A times D, AD. And then you can take the middle two and put them on the bottom and have BC. What do you notice about the answer for method 2 and the answer for method 1? They're the same. They're the exact same thing. Okay? So I need you, the next problem we do, I'm going to do 1 by method 1. We're going to do old school, and we're just going to, instead of stacking it, we're going to write it out and flip it, okay, and multiply it. And then we're going to do the same problem by method 2. What should happen in the end? You should get the same answer, okay? So here is method 1, okay? If it is stacked, and you will see one on your SOL where it's stacked, okay? You will see one on your SOL where it is stacked. All right, so let's rewrite this first. So A plus B over 4 divided by A squared plus B squared over 4. Any questions on that? And then from there, we're just going to copy, change, flip. So A plus B over 4 times 4 over A squared plus B squared. Any questions? Can anything factor? Can you factor A squared plus B squared? They're perfect squares, aren't they? A squared is A times A, and B squared is B times B. So can you factor a sum of two squares? Yay or nay? Can you factor a sum of two squares? Like yesterday in your journal, I asked you to factor x squared plus 9. It's not factorable. You can't do a sum of two squares. You can't do it when it's adding. Remember, there's nothing that works. There's nothing that can cancel the middles that can get the end. So you cannot do that. That is not factorable. You can only do a difference. So this guy right here cannot factor. So at this point in time, let's just multiply across, or let's just cancel and smush it together. What can cancel? 4 and 4. And what will I have left? A plus B over A squared plus B squared. Can I cancel like one of these A's with one of those A's? And one of these B's with one of these B's? Why or why not? And explain, please. Can you cancel? Can I and cancel that? It's your ticket to lunch. Why can't you? Think about it. All right, so my question to you is this. Why can I not go in at this point in time and cancel one of these A's with one of those A's and one of these B's with one of those B's and get 1 over A plus B? Good thinking. Not quite what I was looking for. What did I tell you the other day you could cancel? You can cancel monomials with monomials and binomials with binomials. And in order to cancel out a binomial, they had to match. Exactly. These are inside binomials, and they are protected. Does that make sense? You can't just go up to a binomial, like if you have 4x plus 10 over 6x plus 12, you can't just come up to a binomial and make that a 2 and make that a 3 and cancel those x's and then make that a 5 and make that a 6 and then 2 plus 5 would be 7 and 3 plus 6 would be 9. Yeah, that don't work. Does that make sense? You can't just start taking pieces and parts of a binomial. Binomials are protected within the parentheses from hence where they came from. Does that make sense? Okay, so these are protected. Okay, the only way you can start to simplify is if they were on the outside, because then they would be a monomial. So this is going to be your answer. A plus B divided by A squared plus B squared. Okay, do not worry about the excluded values. This one's a little bit different, and we'll get into it in a couple weeks or so. All right, so let's do method 2 for this. Method 2 says you can use the property. It's the same question. We should come up with the same answer. So if I have fraction divided by a fraction, the shortcut says I can take the very top with the very bottom, and I can put them where? In the numerator. So I would have a 4 times a plus b. Any questions about that? You put that in the numerator, multiply them together. Then you can take the two middles. So I'd have a 4 and an a squared plus b squared. So far, so good. Then just cancel it out. Okay? So what can cancel? The 4's, and so what's my answer? Very good. Why, again, can I not cancel the a's and the b's? Because they're protected within binomials. They're on the inside. Okay, so there's your answer. Any questions? How many, just curious, how many like method 1? Old school, you'd rather just divide it and then copy, change, flip. Sure, if you like it that way, then do it that way. How many kind of like the shortcut? Then I recommend, try it. What if your problem is written like this and you like this and you want to stack it? Can you do this divided by this and stack it? Yeah, if you want to stack every problem, you can stack every problem and use the shortcut. Especially if you're going to trig, I would highly recommend to try to start to use that because that's going to make your math go quicker and easier. Okay? All right, so this is our last example. Yes, sir. Mm-hmm. Because they were monomials. Does that make sense? Let's go back. 2. These were all monomials. So if they're monomials, you can do monomials with monomials. They're on the outside. They're free. Cancel them out. Does that make sense? But if they are binomials, you can't just go and take pieces and parts out of a binomial. Okay? Good question. All right, so let's look at our last example. I'm going to let you try it, and I want you to decide here and now. Do you like method 1? Do you like method 2? Now, I would tell you this. What's different about this one? There is something that is different. Yeah, the square's on the outside of the parentheses. So, this will be a good journal topic for us tomorrow. What do I do with that square on the outside of the parentheses? Yeah, so some people would say, using your properties of exponents, you take the 2 to the x, and you take the 2 to the 2, and you get x squared minus 4. You know what? That actually is not correct. You can only do the distributive and distribute to everything on the inside when it's a monomial. That only works with monomials. Do you understand that? If it's a binomial, you actually have to, when you square something, you're multiplying it what? By itself. So really, if I were you, I would write this, you'd have to write it out twice. X minus 2 times quantity of x minus 2. It's the same thing as x minus 2 squared. You times it by itself. So there's 2 of those up there. Okay? And tomorrow in our journal, we'll talk about why you can't just distribute the 2 to each. Okay? Any questions about that? All right. So see what... All right. Okay, so let me just put the answer up here. We did this one. If you're listening to the recording, we did these on the board. One person did method 1, the other person did method 2, but you should have, if you're doing this at home, you should have ended up finally with 2 times quantity of x minus 2 times quantity of 2x minus 5 divided by x times quantity of x minus 4 times quantity of x minus 1 times quantity of x plus 2, and your excluded values, x cannot equal 0, 4, 1, 2, and you got to put the negative 2 in there. Make sure you do the excluded values before you cancel, okay?